Law of signs, ambiguous case. Okay, let's start off looking at the do now, where we simply use the law of signs to find the value of angle C. So given triangle ABC, we have measure of angle A is 74, side A is 59.2, and side C is 60.3. So here we have the triangle drawn out, and now we can set up our law of signs proportion, which will be 59.2 over sine 74 equals 60.3 over sine C. So we have this set up because of this angle and the side across ratio. We know this is the essence of the law of signs. Okay, so it's always the side opposite the angle. Sorry, I kind of messed it up. Let me just do that one again. More like that. There we go. So we know that it's the side opposite, the angle sine of that angle equals the side opposite over the sine of the angle. And this is how we get this. So then we cross multiply, solve for C, and we end up with the calculator will basically do this for us, and we'll get 0.979 and some change. So we need to do the inverse sine of both sides. And that's what we will do with the calculator. Again, we'll do inverse sine or arc sine. The answer, the previous answer, which gives us 78.3. Okay, that's it for the do now. However, in today's lesson, we are learning all about the ambiguous case. When a triangle is set up with the angle side side order, we have angle is right here, side side. Because we have this angle side-side configuration, like in geometry, this never worked to prove that triangles were congruent. And the reason is because you have this ambiguity where you just don't know if it's this could potentially be 0, 1, or 2 different triangles. So you have to, there's a check step to see if another found angle exists. So like we said, the ambiguous case pertains only to angle side-side triangles. Okay, what you want to do is you subtract out the found angle minus 180 degrees to find the other possible angle. And there's 3 cases: 2 triangles, 1 triangle, or no possible triangle. So here's the same do now, except this is with the question, what is the possible 2 values for measure of angle C? Now we already found one of them, that was 78.3. So what we do is we subtract that away from 180 to find out what the other possible angle is, 101.7. And then we just do a test. We take the original angle of 74, and to that we add 74 plus 78.3. That was the found angle. Determine if that's less than 180. Yes, it is. We do the same thing, 74 plus 101.7. This was the other possible angle, to find out if there's enough room to fit a third angle to produce a triangle. So once again, it has to be less than 180, and 74 plus 101.7 is like 175.7, and that is indeed less than 180. So there are 2 triangles that exist, and both of those possible values for C are 78.3 and 101.7. Number 2, how many distinct triangles can be formed if measure of angle A is 35, A equals 10, and B equals 13. Let's draw the triangle first. There we go. Let's set up our law of signs. Here's our proportion, and we cross multiply to get sine B by itself. So here's sine B. So we want to take this and plug it into the calculator to give us this decimal equivalent. Now we need to do one more step. We need to take the inverse sine of both sides, or arc sine, which we also use a calculator, inverse sine, and the answer is 48.2. So we'll round that to 48 degrees. And because this is an angle side-side formation, this is the ambiguous case. So we'll subtract 48 from 180 to find 132. So we're going to take 48 and 132 and test both of those out. We need to add the original angle of 35 degrees to each one of these. 35 plus 48 is less than 180. Yes, that works. And 35 plus 132 is also less than 180. So we have 2 yeses, and 2 yeses means there are 2 distinct triangles. Number 3, here we have an obtuse angle. So let's draw this triangle knowing that one of the angles is obtuse. 135 degrees is angle B. The sides are 10 and 9, as you can see here with the given information. So let's go ahead and set up our law of sines. 9 over sine 135 equals 10 over sine C. Cross multiply, get the sine C by itself, which the calculator will help us with. 10 sine 135 all divided by 9 is 0.7857, and when we take the inverse sine of that arc sine, we end up with about 52 degrees. So C is approximately 52 degrees. Now, could there be more? Well, maybe. Let's test it out. So we'll do 52 minus, take away from 180, we get 128. So this means we need to take both of our newfound angles, our possible angles, 52 and 128, and add them both to the original 135 degrees to see if it is less than 180. 135 plus 52 is actually 187, and that is greater than 180. That's not going to work. Okay, so I think I screwed that up. That should be less than. So is it less than 180? No, it's not. So that cannot work. Over here, 135 plus 128 is also greater than 180, so that does not work. Again, actually, I think I meant to do that. Okay, so this is greater than 180, greater than 180, so it's a no and no. So the answer is no triangles exist. Number 4. Here we have angle A is 30, side B is 12, and side A is 6. So we can set up our law of sines, and we cross multiply, solve for sine B, plug it in the calculator. We get B is about 90 degrees. We'll take 180 minus 90, we get 90 again. So this is interesting because we end up testing out the exact same angle twice. 30 plus 90 is definitely less than 180. Don't be confused by this. Just because we did 2 tests, I'm really being redundant here. The answer is yes, only one time, but it's the same triangle. So ladies and gentlemen, only one triangle can exist here. The answer is 1. Sage and scribe number 1. Here's the triangle. Here's the law of sines, proportion, cross multiply, solve for sine B. We end up with B is approximately 39 degrees. So we take that, we subtract it from 180, we get 141, and we add 30 to both of these to see if we are less than 180. We have 2 yeses, so the answer is 2 distinct triangles. Sage and scribe number 2. Here's the triangle. Here's the proportion based on the law of sines. Solve for sine B. And when we plug it in our calculator, we end up with the error message. Now, it's not that you did something wrong. It's that no triangles are possible. Because if you think about it, if this were drawn to scale, 68 degrees, we are basically restricted. We cannot open up this angle or close this angle any smaller. This leg of 10 will never ever touch this leg of 24. No matter if you swivel it this way or swing it around this way, it'll never touch this. So therefore, we can never form a triangle. Last one, sage and scribe number 3. Here's our triangle. Here's how we set up our law of sines, proportion. Sine B equals 5 sine 30 over 6. Calculator gives us B is approximately 25 degrees. So I'm going to take 25, I'm going to subtract out from 180, we get 155. Let's test both of these cases out. 30 plus 25 is less than 180, yes, that'll work. But 30 plus 155 is 185, that does not work. So we have one yes, one no. The answer is 1. Good luck to you today.